Alright, this podcast is dealing with Section 8.4 in our textbook called Areas of Triangles. Some of you guys may already know what the area formula for a triangle is. It's 1/2 base times height. My purpose in doing this is I just wanted to show you guys where the area formula actually comes from and why it works for all triangles. We're going to start with a right triangle actually. So I got my sides labeled already. My base is B, my height's H. Now, where the 1/2 base times height comes from is if I actually take this right triangle here and I rotate it around the midpoint of that hypotenuse. Watch what happens. Rotate it 180 degrees. What I actually form here is a rectangle. If you remember back to a few days ago here, the area formula for a rectangle is just area equals base times height. And if you look, there's two of these identical triangles inside that rectangle. So each of these triangles account for half of the entire area. So that's where the 1/2 base times height comes from. Okay, different scenario here, because here the height of my triangle is on the triangle. Here are the heights on the inside of the triangle. Similar process here though. I'm still going to make use of the fact I've got right triangles here. So if I know the area of a right triangle is 1/2 base times height, I can figure out the area of this big triangle by taking these two little triangles, these two little right ones, finding the individual areas and just adding them together. Okay, and what that looks like here, area of the small triangle, or ABD, is 0.5xh, because again, the base here I just label as x, the height is h, so 1/2 times x times h would be the area of this little right triangle on the left side. The area of the right triangle on the right side, well, if you look, they both got the same height, is 1/2 base times height. Well, the base here is y, so 1/2 times y times h. Okay, and what we want to do to find the area of the big one is take the two little ones, add them up. And that's what I've done here. I've got my 0.5xh plus and my 0.5yh. Here, I'm just adding them together and just doing a little bit of algebra. If you look, both of these terms here, they've got a 0.5 in them and they've got an h in them, so I'm going to factor that thing out. So I pulled that on the outside. Oops, gotta undo that stupid thing. Okay, I pulled that 0.5h on the outside and I'm left with x plus y here. Okay, but what in the heck's x plus y? X plus y, if you look, well, this was x, this is y. If I add those together, I get my length of my base here. So I just took x plus y and I replaced it with b. So my area for this is 0.5 base times height also. So what we've so far shown is that the area of a right triangle is 1/2 base times height, and the area of a triangle, if the height's on the inside, is also 1/2 base times height. The only other option we've got is the height could be on the outside of the triangle. It's either got to be on it, in it, or outside of it. So here's a picture of one that's got the height on the outside. Now, and if you look, I can find a couple right triangles here. I've got this small right triangle on the outside I've got dashed here. A big right triangle would be a triangle ADC, going from here to here all the way over to here. I got this big one, and so the way I'd find the area of my triangle ABC, I'd take that big right triangle and I'm going to subtract the area of the small right triangle right out of there. And again, the areas of my two triangles here, well, the small one is 1/2 base times height, so 1/2 x times h. The area of my big right triangle here is still 1/2 base times height, but my base here is x plus b units long. So it's 1/2 times the quantity x plus b, then times h. I'm going back to my lovely thing in Word. I've done all that down here. See, I've got my two triangles. I got one is 0.5xh and the other one is 0.5 times the quantity b plus x, because that's how long the bottom of this big triangle is. Here was my b plus x. Okay, so to figure out my area, I take the area of my big one, which is this one, and I subtract the area of my small one, which is this one. Okay, so if you look, here's the area of my big one minus the area of my small one, which is right here. And I'm just going to do a little bit of algebra here, because I'm going to take this thing, this 0.5h, I'm going to distribute it inside the parentheses to the b, and I'm also going to distribute it to the x. So what you end up with is this thing here in the parentheses, 0.5bh plus 0.5xh. But if you remember what we got to do, again, this is just a different form of the area of the big triangle. I have to subtract a small triangle from it. Well, the small triangle is 0.5xh right here. And if you look, I have a plus 0.5xh and a minus 0.5xh. Those are going to wipe each other out. They're gone. So all I'm left with is 0.5bh. So 1/2 base times height. So it doesn't matter if my triangle looks like this with the height on the outside, it's 1/2 base times height. The height's on the inside, still same thing, 1/2 the base times the height. Or the height can be on the figure like it is on this triangle here. It's 1/2 base times height. And that's it. There's actually another different type of area formula that really blow your mind. Just if you get bored, look up on the internet Heron's formula. It's kind of funky. It's got like square roots and stuff and semi-perimeters and all that. But there, you know what? You don't need to worry about the height. It's just you need to know the lengths of the three sides.